We are Genvid. We were formed in 2016 from a game industry veteran from Square Enix. Previously, we're working on cloud gaming at Square Enix, and we decided to start a new company called Genvid. Our main office is in New York. All the development is done in Montreal, and we also have some office in Los Angeles and Tokyo. Since then, we are backed by Maker Funds, Horizon Venture, March Capital, and OCA Ventures, all great investors that really believe in our visions and our capacity to create a real new experience that will, we hope so, change the world of media streaming. We are now we have doubled our size since last year, so now we are about 30 people, and we're still growing. There's even some new hiring that is not present on this slide, so they will start, I think, next week. And so basically who I am. My name is Fabien Ninoles. I'm a Genvid co-founder and the CTO of the company. I got 10 years of experience in the game industry. I work both in production with TIFF and in various technical groups, cloud gaming, in system libraries, online technology. Previously, I was part of the multimedia industry. I also work in high-fidelity electronics and also embedded software. I love Poutine. I'm from Montreal. I'm a Quebecer. And here's my cat. He has way better he do better portrait than me, and she's just doing an impression of me after eating this Poutine. So what we will do today, interactive streaming, it's a new kind of technology. We are experimenting with it. I'm thinking about this technology since even from my previous employee, we were doing cloud gaming. We were thinking about, okay, what we can do to make some money. We are not Google. We cannot afford 25 megabit PS per viewer for cloud gaming and all this stuff. It will cost way too much for us doing this. So we were looking at, maybe we can stream the cloud experience and make it interactive, and that's all the idea behind Genvid work great. We want to see what we can do with the video, what we can do to make people not only watch the video, but interact with it, be more interactive with it and play. And since we are in the game industry, interactivity is core of what we are thinking. So we were considering that we are in the best position for create this kind of experience. But even after all those years, we are trying to figure out what's the best way of using this kind of interactivity that we have created. What's the challenge of it? What we need to think about it? How do we design an interactive experience, an interactive streaming? So we will see the different elements that we have identified among the years with different developers about what are the important elements of design of an interactive streaming. We will see a little bit the challenge of interactive streaming, at least for the technology of today, the limitation of our today streaming. And quite quickly after that, we can see how we integrate on the game side, how to build a website for doing interactive streaming, and finally, how to deploy on the cloud, which is the big bad wolf here. So, I forget, I have to remind you, this session is actually being recorded, so please close your cells. There will be a small period of question after that, or you can come to the booth. I will be there also for answering questions. I'm missing something? Don't forget to evolve, because I will probably forget to remind you at the end of the session. So I'm doing it right now. I will try to remind it to be reminded about it at the end of the session. So let's start. So elements of interactive streaming. There's many things inside an interactive streaming. When you want to create a new interactive streaming experience, you have to think in front about what it will be. Part of it is about the content of the stream. There's the perspective of the stream, what you want to show, how you want to show it, what kind of interaction you want to create, what is the duration of the stream. It will be 24/7, small stream, and how do you want to deploy the stream, the full engine behind it. And in center to all of this, there's a question of money. And you would say, hey, this is a tech talk, it's not a business talk. What he's doing with this money sign is like, no, this money, cost, revenue, it's all part of the design. It's your constraint that you have to live with. So we'll start with this last one. So money, cost and monetization, and monetization, especially for streaming, is all about scale. There's different scale for different kind of experience. If we're looking at the scale of interactive streaming, you will see that the server cost is a lot linked to the number of streams that you have. If you have a single stream, you have less server than if you have multiple streams. The server are the one doing the encoding and all this stuff, so the number of streams that you want to push out will create a big part of your cost. But the real cost, in my opinion, if you have a popular stream, is the bandwidth cost. It's proportional to the number of viewers, and you want to have a lot of viewers. You don't want to have a stream just for your friend and that's it. You want to have thousands and hundreds of thousands of viewers concurrent looking at your stream and seeing it. And so most of your costs will come from the bandwidth of your viewers. But it's also nice, so where you want to do is to link your incomes to your viewers so that you are sure that you can monetize with microtransaction and other technology to afford it. So your incomes will go with your bandwidth. So the conclusion of this is you have to make your video stream itself, what's going on the screen, appealing to a maximum of viewers. So you will remove a lot of it to just create the base experience, and instead you will try to appeal to different viewers with over the stream content. So a beginner will have a more hands-on experience with more information on the screen, when the expert will have only what he needs to see to really appreciate the competition going on or the tournament. So I will say the most important part of interactive streaming is what you want to show. Is it did I want to show which kind of gameplay I want to show? Do I want to show the campaign going on and people can participate to it? Do you want to show an online match or a tournament? Which kind of HUD you want to show? Do you want any HUD or do you want just the HUD? What kind of information you want to add to it? Do you want to have a tutorial for showing to people what your game is doing, what's happening on the screen, what kind of weapon the user or the player are currently using in your stream? Do you want to have some statistic about this player, like if you are in a big league, how the first player is ranking compared to the other? What is its HUD to win the end of match and this kind of stuff? Do you want to have a broadcaster that will comment the match at the same time, or even being played, or maybe it will be a host panel commenting on the match, like in a hockey game or a football game. I'm Canadian, so it's all about hockey. How many streams or cameras do you want to have in your stream? Genvid support picture-in-picture and different we will soon support mosaic and this kind of stuff. So you can have multiple cameras, but you can also have multiple channels so that the viewer can choose a different channel to see a different stream. So that's all element of the content of the streams. When you set the content after that, it's a lot. We are talking about content and camera, and that's where it's happening. One good example of a change of perspective that's almost necessary, if you have a VR game, the best experience is not to show up what the player is actually viewing, because you will get most of your people sick if you're doing that. So you want to create a third camera, either up front, a third-person view, maybe a first-person view, but without too much dribble and smoother turn and all this stuff. And you can even have many of them in this perspective. You can have also a top-down view so that people can follow the whole match and even have like X-ray vision about what the match is going. You can have also a drone camera that maybe can be controlled by the viewers a little bit, so they vote for where the drone camera is going next and all this stuff. And you can also have a mix of all of this, like a top-down view with a picture-in-picture of the player, or the players with a picture-in-picture of the top-down view, like we see in the bottom image. The next element, we are game. So interaction is important, and there's really different kind of interaction, different kind of engagement you can have from your viewers. It can be purely passive. It can be just, okay, I show you stats, you can appreciate the match more, I will give you some information of this. It can be communal, and so all the viewers can interact with each other, a little bit like a chat, but more interesting. So because not text, it's actually happening on the screen, so they can cheer for each other and see other viewer cheering for their favorite. So maybe you can even find a way to create a wave inside of it, like in the stadium. And it can also be active. Why not let the viewer interact with your game? They can do like in Hunger Game, where they can, this player is wounded, so I will send him a health kit, and you pay for it, and you send a health kit. Although we don't support it right now, we have some plan to finally start giving interactive not only on live stream, but also on offline stream. So maybe you can start also thinking about, okay, what will be the experience once the stream is on live and the viewer can no longer interact with the game? Can I still let them play a little bit, have information? So what will be their experience at this point? One of the final elements is the duration of the stream. You can have a stream that lasts for all the tournament, so only all the match, and with some commentary between the match and stuff like this. You can have a recurrent broadcast, like every Friday evening, people come in and you participate in an RPG all together with the viewers playing, deciding of the action of the NPC, for example. Or you can have a 24/7 stream where you interrogate your matchmaking server and find the best match to play with. And you just showing the best moment of the match and all this stuff, and finding the most interesting moment. For sure, this is where the costs will really change. Going for a 24/7 stream will probably cost you way more than doing a tournament, but maybe the tournament would bring a lot more people to it. And the final point is, well, how you make this possible. Genvid is not a service. We are, maybe that will come in the future. We are a middleware company. So we invite you to think about, okay, I will deploy this, I will maintain the server. We give you the tools for doing it. We give you all the service, we give you script. We even have a team to help you on that. But you have to think a little bit about what you want. So do you want to have a purely on the cloud, on-site deployment that's useful for tournament, for example? Do you want to have a broadcaster? All the broadcaster will access the servers. Do you have a spectator client? Embed? Do you want to have an embedded site, which a little bit like simply you have a website and you embed the YouTube player, for example, in the middle? Or you want to have in-stream, a little bit like Twitch, what we allow on Twitch extension, where Twitch allow us to have an overlay directly on Twitch site, which allow you to bring all the Twitch community directly in your experience. And also, especially if you're using an embed site, but even on Twitch, how people will discover that you stream, you actually interactive, and you create this kind of experience. So, how to publish it and to market it. So that's all the part of the deployment. So that was the about 6 elements of interactivity, but it's time to come to the difficult question of the challenge of interactivity. Genvid has fixed one of the big problems in interactivity, which is the precisions. You have different kind of latency, and we were able to synchronize perfectly, well, almost perfectly, the video frame and the data so that you can create this kind of gem content. But there is still two challenges that we have no way to fix, because if we're doing it, it will probably break the law of physics. So one of the challenges is the high latency. You have a broadcast latency right now for most service. If you go in the low latency settings and high experience, you have a broadcast latency that can be down to 1 or 2 seconds, or even almost below the second in some case, but it doesn't scale that much. More popular you are, higher is the latency. That's a reality. And not everyone will experience the same latency. If someone has some problem with his internet, he will start buffering and will start to have higher latency than its neighbor that is using a fiber direct connection. So it's really depends on your ISP or where you are and stuff like this. And we also have to think about what about offline playback? What about if they find the stream again? Will they have something? As I say, that's something we want to support in the future. So maybe we will have a better solution next year on that. The other challenge that exists is the high concurrency. You can no longer have like, oh, you hear your controller and you interact with it. A couple of years ago, there were Twitch Play Pokemon, and you can see a lot of people chatting to try to influence the Pokemon game, play the Pokemon game together. But a little bit it feels like you're lost in the crowd when you try to do the experience, because you try to go up, and everyone else is going down, and you feel that you're completely lost. So how do you engage with thousands of people? How do you make your single stream experience relevant for thousands of people so that they can interact and they can see the change of it? How someone can feel invested when his action is drawn among thousands of other people? So you have to create some interactivity with them directly for him to see, yes, your action is taken into account, and here is the effect of it among all the crowd. And can crowd cooperate together? Can they create? They were able to play Pokemon, but it was like taking a ton of years. I cannot show the video link here, but the presentation will be online. And it shows a video of the BBC, a study they made in a small theater where people have a green and red palette that can switch red and green. And if you put green, there were a Pong game on the screen, and the palette was going up. And if you put red, it's going down. And it was the balance of the group. And they divide the room in two. And half was playing the left palette, the other was playing the right palette, and they were able this way to play pong, to coordinate themselves so that they can hit the ball and play against each others. So a crowd can cooperate. So you however have to find the right model for it. So it can be a good challenge how to make the wave happening in your game with this. So InSoft solution, based on the experience we have with our different clients, the different interactive experience they have created, is to try to limit the options available. Instead of having the full control on the size of the palette, just green and red for up and down, a single option, single vote. You keep the interaction loop close to the viewer. That's a little bit like when Web 2.0 was happening, when they start to see, oh, it's too long to go back to the server and coming back to the web client. It's a little bit the same thing. You send the command to the server, but in the meantime, you create a small activity, a small interaction, so that's before the video, the game responds to it. You have the player has the impression, the viewer has the impression that something is happening. So you provide early feedback about this. For addressing a lot of the other challenge, all the interactivity, we have created different kind of tools, and those tools are basically our API, our model that we have of what you can do and not do with Genvid. We have data streams that are synchronized and reliable, annotation that are also synchronized with the video stream, but happen only once. Notifications are immediate and react directly with the user. The events are collect together, summarize, and send immediately to the game. And you can even send comments, but from a restrict point of view, because it doesn't scale elsewhere. The first one at the top are made for thousands of people. The last one is only for when you want to have only a couple of interactions. Elsewhere, you have a lot of risk to inundate your game. And that's the kind of thing you don't want to happen. Yep. So, as I say, the data stream are always synchronized with the video, and you always get the most recent. That means that if at some point the stream is cut, you were back online, you will still have the last stream. It's very useful to synchronize game state. You don't put just a difference, you put the whole game state of it. So every time someone connects, you will already have the whole game state that is available for you to play on your UI. Annotation is a little bit different. You only get all the annotation that came between the last time you request them. So, for example, between 2 frames. So it's very good to send game events, like the match is beginning now, a player has been killed right away, on this kind of thing. Both data stream and annotation are also available on receptions. So we try to push it as soon as possible to the website, but the video is often coming later, like 2 seconds, 5 seconds later. So you can use the quick reception to create a timer, for example, to say the player will be killed in 5 seconds or something like that. The other tool was the notification. Notifications are immediately sent to all viewers. However, they do not persist and they are not synchronized by definition. So you will get a notification. For example, you can send, for example, the game has finished, so stop sending me any voting. So a end of voting period. It allows you to create more direct interactivity with the viewer. They are also available as a web API, so that you can also have other systems communicate to all the viewers to present, for example, cheers or anything like that to all the viewers together. And finally, there's the events. As I said, the events are collect anonymously from all viewers. The goal is not to send like the list of all the viewers that has, for example, cheer player 1 and all the viewers that have cheer player 2. Instead, we sending a summary periodically. In the last second, 100 viewers have voted for player 1 and 150 viewers has voted for player 2. So you can, this way, inform the game about the crowd behavior, the general behavior of the crowd. And the last one was the comments, which is basically just allow you to interact with the game the way you want. It just sends a single data to the game, and you can send, for example, please restart the match, or please change the map, or so it's really at your leisure how you want to use it. And for sure, Genvid doesn't try to be all-encompassing solution. So we're doing one thing, we're doing it well, is data synchronization and event reductions. But you can use all the other interactive tools. You are not fixed to what the platform offer. Genvid is just a middleware, and like any middleware, our goal is to work well with the other middleware. So you have a matchmaking server, you can interrogate. Don't hesitate to use leaderboard, game service, voting system, polling service, live streaming API from Twitch. The world is rich of web service and different tools for managing this. We just part of it, and we try to play well with the other ones. So that closes the first part about all the design and what you can do. And now it's time to build your Genvid experience. So you download the SDK, and you will have to do three things. You have to integrate inside your engine. You have to build the website experience. And finally, you have to deploy it. The engine integration, if you were there 2 years ago, I made a technical primer about this part entirely, and almost nothing has changed since then. So it's all the same. Our API is very, very stable. We have a version 2 in preparation, but it will contain a compatibility layer that will allow you to have the same. I have some demo that we are still running from 3 years ago, and we just update the DLL, the Genvid DLL on it, and they are still working. The engine, for doing the engine integration, the first thing is for sure the initialization and termination. It's a simple call, Genvid initialize, return a Genvid status, which is our error type, and you just have to check if it's failed and handle it. Always check everybody is checking their error when they are using API. I hope so. The integration of the video stream. Genvid support different kind of video capture interface. So this one show how to use DXGI swap chains. Right now, all our capture, however, are based on DirectX 11. However, we have some games that have implemented capture through OpenGL using a raw buffer interface. So for creating a video stream, you call create stream video for whatever name you want to give it. It can be camera 1, for example. You set the frame rate. You set the type of capture. In this case, it's a parameter called video source IDXGI swap chain. And in this case, you take a parameter which is the DXGI swap chain, actually. Once you set this, every time you will call submit video data on this particular stream name, it will do the capture of the stream and will send it to the encoder. So you just have to call it every present call. So when you are ready. We also support capture from a texture buffer, the X11 texture buffer, or you can also just capture it yourself and send us the raw buffer of the image. We support RGBA, NV12, and a couple of other pixel formats. And you're welcome to propose other pixel formats if you feel we need some more. And yes, for sure, at the end you have to, before calling the termination, you have to destroy your stream with the destroy stream video. On the audio side, audio is always a little bit more difficult to capture because he cannot support to have delay in between and all this stuff. So it's even simpler. So you create the stream, you call it the name you want, and then you can say, okay, I want to capture from the audio source Wasapi. Will capture from the Windows system Wasapi, so we will capture your whole speaker doing it. That's the simpler way of doing it. So because we're doing all the capture and synchronization behind the scene for you on that. However, we also support raw buffer, and we start supporting it in different game engine like Unity, and it's allow you to have only the sound of the game or even the sound that you want. In the future, we would like to support more than one audio stream, so you will be able to separate sound, music, and make some adjustment to it. And we also, and for sure, every stream also have a destroy stream for termination. On the data side, we have data stream, annotation, and notification. They have all the same, very similar calls. You have a create stream. You set the frame rate. The frame rate will determine when a data will be repeat if you doesn't have sent a new one since the last time for the Summit game data. So you can do Summit game data. We don't touch to your data. You can send everything, binaries, null buffer, whatever. So you can use JSON, you can use protobuf, you can use your favorite format for serialization. As you will be able to retrieve it as is on the website. Same thing for annotations. You can, however, send multiple annotations per frame instead of a single one. And notifications are sent directly, so they have no time code. The first argument is the time code. Passing -1 basically just say use the current time for this data. So you can send the Summit notification, and for sure at the end you can destroy the stream. One aspect to check: some notification are not a stream, so they don't need to have like a create stream before them. You just give them a name, and it will be sent this way. Events and commands. That's basically how the game receive the new events and even the commands of it. So it's made with a callback system. You do a subscribe, you set your callback to it, which is a small function taking, for example, for event, Genvid event summary and a user data that you can pass what you want to it. And same thing for the command callback. We should take a command result and we'll send the user data to it. So you call Genvid subscribe command. And the callback will always only be called inside the thread where you call Genvid check for event. So that's allow you to control multi-threading issue with it. So you call Genvid check for events when you are ready to receive the command, and if there is a new command coming in or a new event coming in, your callback will be called inside this thread. And for sure, before termination, you just have to call Genvid unsubscribe with the callback or Genvid unsubscribe command for the command callback. Finally, we have done some big work integrating the basic integration of inside a custom game engine. It's most of our developers do it between 1 and 3 days, so it's not a lot of work. But we decide to help you a bit more, and we have created plugin for Unity and Unreal Engine. The Unity plugin even contains, as I said, the Unity audio engine support. And inside it, we also have some editor tool to have access to what we call the toolbox, which allow you to start the Genvid service directly from the editor. So we are now we have finished our game integration. We have created some events, some data that we want to use for interaction. It's now time to do the integration of the website. Genvid provide a single service, the Disco service, as a private API, and you have the job to create an API gateway, a small website, for transforming what you want in the call. So your web client will have to call, for example, a join call. The API gateway can do some authentication to the authentication service that you want to use. You can also just skip it if you don't want to use authentication. And after that, you do a join call to the Disco service, and you receive some session info and the security token. And you just have to, if you want to modify it, you can. You just do an update, you add some information, you modify an URL to take into account your proxy, and you just have to, you return that to the web client. On the website itself, inside the browser, after that, you can take the session info that was returned, as well as a URI and the security token, and you just create the Genvid client, passing in the div element that you want to use for integrating the video. So after that, you have a different callback that you can set up for your different event happening in the client. So we have a callback for when the video player is ready and has been loaded and is ready to be mute or unmute. So it's a good place to do some initialization after the web player was loaded. We also have a callback for when the WebSocket successfully opened. It's called unauthenticated, and it showed that the connection was successful to the WebSocket for receiving data. We have an on-stream receive. As I say, all the data is sent as soon as possible to the web client, and that's a place where you can hook to see what's coming in the future on-draw call. You have notifications received when you receive a new notification from the game, and you also have finally the on-draw call, which is called every time there is you can set the frame rate at which it will be called. So for example, you can set it to 30 FPS or 25 FPS if you want to slow down. And it will give you the frame containing all the most recent data and annotations coming from the game, as well as a matrix of where they are on the screen, how the screen was composed. So for example, if you have a picture-in-picture, it will tell you where the picture-in-picture is and what information is inside this picture-in-picture. And finally, you can just start the client and you're good to go on that. On the event side, basically, we have a call called send event that allow you to send the event. And based on the configuration that you provide, the events are simply remapped to different, so that you can create from one event, you can create different key. And each key after that collect together and reduce using either a sum, a min, a max, or sum, min, max, or count method. And you have it is then sent to a root server and sent back to the game after some time. Deploying the Genvid experience. So we have our game, we have our website, everything is there. Now we want to test it a little bit. So how are we doing it? And probably you have tested a little bit before, but now is a real test. So we support different type of deployment. We support a local deployment for developer, a small cloud deployment just for doing a demo. And we also talk about the big deployment in production where you want to scale to 1,000 of people. So before talking about the different kind of deployment, this is an overview of all the different service in Genvid is. So you have your game engine, where you have integrate your SDK. You have your web server at the bottom, where you have where you talking to what we call the Genvid Engage service, and you have your website on the right, the HTML JS overlay, where everything is happening, and basically the SDK is responsible for sending the data to Engage and the video and audio to Compose, which will encode it, send it to a live stream service like Twitch, and the live stream service will be load through our web SDK and playing the video, and you will be able to access the data from it. So when you talk about deployment, we're talking about orchestrations. Genvid is not so very dependent on a particular orchestration service. You can use Docker Swarm, you can use Kubernetes if you want. All our image are Docker image and running on Linux. And we also have a Windows version for running locally. But we decide to integrate the HashiCorp stack with Nomad, Console, and Vault. Nomad is used for running the Genvid service. Vault is used for secret management, and we're using Nomad to provide it to our different service. And we use Console both as a service registration and for configuration. Console contains both Kiwi store, and so we put all our configuration in it. For sure, this thing can be, right now they are a little bit stuck together, but we try to make it so that you can replace it with your own service or your own way of doing orchestration. And when you are on the cloud, finally, you have a different type of server. Our default configuration is composed of 5 different types of server. We have the supervision server that's running the Nomad, Console, and Vault servers. We have the internal workers, which are general purpose machine that run most of our basic service. The encoding worker, which are used for encoding, and so they are more CPU intensive. And we also have the public workers, which are the one at the edge, and they are the one where they are distributing the WebSocket connection. And finally, we have the Windows server running with GPU running the game itself. And for managing those services, we provide two applications and with a UI interface in the form of a website, so that can be accessed remotely. One is called the Bastion API. Is there to manage asset and cluster. It interact with its interface Terraform, which we are using as our default deployment environment, deployment tools, and you just need one per environment. And we also have the Cluster API, which is used for managing cluster asset and configuration. It interfaces mostly with the other supervision service, so Nomad, Console, and Vault. I want to deploy, I want to run it on my machine before showing it to the world. In doing it, we have a couple of Python scripts for doing the heavy lifting on this. You start what you call the local Bastion. This is the first service. You start the Bastion API and the Cluster API. So you do a Genvid Bastion install and Genvid Bastion monitor. This will start Console, Nomad, Vault locally and open the web interface so you can start interacting with this. For starting a local cluster so that you can run it on your machine, you just do a Genvid SDK setup, Genvid SDK load config SDK, which will set the default configuration. And you can also open the web interface so that you can tweak and look for it. And finally, the only thing that's left is running your game. So you load your configuration, the option that you want, and you just start the service. After that, you can do npm run start for starting your website and my game. The way our library and our SDK is done, it will already be able to find, if you're using the default configuration, to find everything. And if you see how I was doing it, you have no VM, you no need for a VM, a Docker or Hyper-V environment. You don't need to have special permission for debugging your game and running it. Everything will run locally inside its own in the natural environment. And so you can put all your debugger, you don't have to deal with VM host and VTX permission inside your BIOS and these kind of things. After that, it may be time to show to friends and family a small demo. So in Genvid, we provide different configuration for doing this. We have a basic cluster that creates a VPC with a basic set of servers. It's about 5 servers running on AWS. And it's ideal for small demo or simple testing. It's not made to scale by itself. Although we use a variation of it for scaling even to 1,000 of people, but it's very compact. And we also have a minimal cluster, which only create the server and security group, so it doesn't create any VPC subnets or YAM roles. So it's ideal if your sysadmin is a little bit paranoid and doesn't want you to play with creating a new VPC and things like that. We have after that, we have you probably want to control your game and your website remotely. So we propose to create a web job in Nomad. So that allows you to run with the same technology that we're using for running our own service. You can use it for running your website, even your game. So we have a couple of samples with example of a web job. It's basically running an API gateway in Node.js and your website. You better to use a Linux container, it will be easier. And you can also, even if you decide to go serverless, you can do it also. The other, for the game are running on Windows, so we were using the Windows executor in Nomad. And asset can be either pre-installed already on the Windows server. They can be updated through a batch job in Nomad. You can also simply always download all the artifacts of the game if your game is small enough, or maybe just the executable if the artifact doesn't change that much. So that's good for the demo. When going in production, you need to go a little bit further. As we say previously, you need to think about the website discovery. It's almost similar to the demo, but you need to go a little bit further. How do you scale? How do you monitor it? How do you keep the information of the logs and all this stuff? And how do you do load testing? We provide samples and tools of how to integrate different solutions, but you can use your own for doing this. And we are here to help. We have a LiveOps team that is responsible, and they can even help you deploying your own stuff. We have a client integration team also for helping you creating the website and creating the configuration necessary. So we are here to help you. Don't hesitate to contact us on that. And finally, Genvid provides also a studio interface for doing picture-in-picture, chroma key, sound balance, and new feature will be added. We have an RTMP and ingest server so that you can add the OBS stream to it. We have a sample for metrics using the TIC or time series database, and also a load testing sample that you can use for creating your own sample on your side. So, yeah, that's the end. Any questions? Thank you.